Before we get into U-sub, it is first important to note integrals for these different transcendental functions, right? Transcendental meaning they transcend, right? Your typical polynomial algebra. Integral e to the x dx, well, e to the x plus c, right? The derivative of e to the x is e to the x, so the antiderivative of e to the x is e to the x, no big deal. Antiderivative of sine, well, think to yourself, what do I take the derivative of to get to sine? So I feel like it's cosine x plus c, but the derivative of cosine is negative sine, so I'll have to go negative cosine x plus c. The antiderivative of cosine x, well, the derivative of what function would be cosine? That would be sine x plus c. Back to the action. Okay, antiderivative of 1 over x. I feel like it's a rewrite. I feel like I want to rewrite this as to be like the integral of x to the negative first dx. But think about what happens then. If you have that and you add 1, divide, add 1, 0, divide by 0, that's where the world comes to an end.
Is it natural log?
Yeah, it's the natural log specifically of the absolute value of x plus c. So this is what we don't want to rewrite. And we'll talk more later about why it's the absolute value of x. It has to do with the domain of natural log, only kind of accepting those positive numbers. And like I said, we'll talk about that more. But these four are kind of important for your work online this week, but also so we can attack some of these like more complicated composite functions. So far so good? Okay. So, what's the antiderivative then? If we know this, what's the antiderivative of e to the 3x? Okay. E to the 3x plus c times what?
3.
Are you sure? Times 3. Check it. What would the derivative of this be? Would it be this? Are you with me that the derivative of this function would really be 9 e to the 3x? Yeah? Okay, so how do we change this so that we get rid of it? Bingo. 1/3 e to the 3x. We have the integral of e to the 3x dx. We got 1/3 e to the 3x plus c. We're able to sort of like think through that process. However, if it becomes more difficult, that process is going to become tougher and tougher to think through. So the method that we have for dealing with it, we're going to deal with it like on a light case, and then we're going to get tougher, is called U-substitution. So here's how this is going to work. I'm going to pretend just for a second like I don't know what this antiderivative is. I'm going to, in order to do this U-substitution, I'm going to pick a u. U is going to be like the mini inside function typically. It might be inside an e as an exponent, it might be inside a trig function, it might be in a denominator, but that u is meant to simplify things. We're going to change all of our x's and dx to u, and then we're going to integrate. We're going to, in other words, we're going to find this, and we're going to take this and make it into something that we can integrate pretty easily. So if u is 3x, the next thing I need to do is I need to get dx out of here. In order to do that, I'm going to show you a step that I'll do this time, but I won't typically do in the future. I'm going to take the derivative of u with respect to x. The derivative of u with respect to x implicitly is going to be 1 du dx. And that's going to be equal to, well, the derivative of 3x with respect to x would just be 3. If I separate my differentials on the left-hand side, I could rewrite this as du equals 3 dx. The reason why that's important is back in this problem, I need to get this 3x out, but I also need to get dx out of here. I need to transfer all my x's and put them in terms of u. So let's start making some substitutions. E to the 3x. 3x is just u. So I can rewrite this integral as the integral of e to the u. I don't yet have dx by itself. I need to bring dx and get it out of here. So let's use this line and just do a little manipulation. If we divide by 3 on both sides, I could rewrite this as 1/3 du equals dx. And now I can substitute. I know dx can like go out and 1/3 du can take its place. I'm gonna be smart with how I write this, knowing that I'm gonna take the antiderivative in a minute. So I'm gonna write this as 1/3 out front as a constant multiple with the du behind. That way when I take the antiderivative of this thing, I can think about it as just the antiderivative of e to the u times an extra 1/3.
This concludes our monthly fire drill. Have a safe rest of the day.
This is going to be such a pain to edit. So I have the integral of 1/3 times the integral of e to the u du. I need to now find the antiderivative, but we know the antiderivative of e to the x is just e to the x, so e to the u would just be e to the u. So how about 1/3 e to the u plus c? And I'm almost done. I just got to finish by having my final answer in terms of x. I was asked about an integral in terms of x. I got to finish with an integral in terms of x. But u is equal to 3x, so I'll substitute and end up there. Interestingly enough, it's the same thing I started out with, right? We knew that was going to be the answer. The U-sub is just going to help us get there when it's more complicated. Now you might be able to look at this and just be like, I know that's the antiderivative. Great, go for it, wonderful. But it's not always that simple. How about the integral of x times sine of x squared plus 3 dx? More complicated now. If this were a derivative, this would be like a product chain derivative, but it's not, it's antiderivative. And the method that we have for evaluating complicated antiderivatives is U-substitution. That's it for right now. So, first question is, I see this, what do I want to make U?
X.
Careful. U will never just be X. The reason for that is, if I make U X, this just becomes U times sine of U squared plus 3. It doesn't change anything, it just changes the letter. I want to pick a more complicated U, typically like the inside of a function, so to speak, quote unquote, because I want to make this less complicated. If I can take the inside and make it less complicated, this overall is going to get less complicated. Pick what you think U would be, and then like trust the process here. What do you think U would be?
X squared plus 3.
Bingo. X squared plus 3. Now I told you before, I did this process here. I showed this step in red, and I'm not going to show that process anymore. I'm just going to go right to the du. Because I know it's always going to be du dx equals, and I'll bring the dx over. So I'm going to go right to du equals the derivative of this right side, in this case 2x dx. Okay, so I got u, I got du. Let's start to make some substitutions. I have the integral of, well, let's see, sine of x squared plus 3, that's just u, so I can get rid of that. But I still have this, like, this x and this dx running around. du equals 2x dx. So what if I manipulated this du and I made it equal to x dx? And then because this is all multiplied, I substitute for x dx for whatever it was equal to. I can get there by dividing both sides by 2 or multiplying by 1/2. So I have 1/2 du equals x dx. So this x dx that was here, I can substitute this right out. I can take this out and I can make the trade. in its place, in x dx's place, is gonna be a du out back, and I'll rewrite this with the integral here and a 1/2 out front. And what we've done is we've made this into an integral that we can do really easily now. We said earlier that the antiderivative of sine was negative cosine. So the antiderivative of 1/2 sine of u is going to be negative 1/2 cosine of u plus c. I can kind of check my math there by taking the derivative. Is the derivative of this here? That checks out for me. But I'm almost done. I have u hanging on. I gotta substitute back and get my final answer in terms of x. Negative 1/2 cosine of x squared plus 3 plus c. So far, so good. Okay, I have one little twist for you today. I got one twist. The twist comes when I put on limits of integration. So how about the integral from 2 to 4 of the square root of 2x minus 1 dx? One more problem. Okay, start us off. What's u gonna be?
2x minus 1.
Yeah, they said in unison, 2x minus 1. So du is gonna be equal to 2 dx. You with me that I don't have 2 dx, I only have dx. So I'm gonna look ahead, and before I even start substituting, I'm gonna rewrite this as 1/2 du equals dx. So that I can now substitute for u and for 2x minus 1 and for dx. Okay, let's make the substitution. The integral of, I'm going to do a 2 for 1. I'm going to put u in here, but I'm also going to rewrite this with a fractional exponent because I know that's what's coming, right? I'm going to have to add 1 divide. I know that's how I'm going to have to rewrite that square root. Dx is out, 1/2 du in the mix. Now you might say, Mr. Lewis, but you forgot your limits of integration. Here's the tricky part here, or the extra sort of, I don't know, trick that they can throw in. When I complete this problem, I have a choice. I can either sort of pretend this 2 and 4 here. I can do my integral in terms of u. I can substitute it back in terms of x and then evaluate my final answer at 4 minus at 2. Or I can warp. Do you ever see Mario? Like old school Nintendo Mario, right? He goes through like the tubes, like blah, 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 through the tubes to different levels. And sometimes the levels are different. Like sometimes it's like regular level, regular size Mario, then there's like flying Mario and underwater Mario and super huge Mario where everything's like enormous, right? This problem started out in X land. What we're gonna do is we're gonna warp to U world and we're gonna never come back. We're gonna run through and jump on the flag and save the princess in U world and not come back to X land. To do that, every single part of my problem has to change from X to U. This has gotta change, dx has gotta change. But my limits of integration also have to change. Right now they're X limits of integration. I need to make them U limits of integration. To do that, I'm going to use that relationship that I know between U and X. If X equals 2, and I put 2 in for X, 2 times 2 is 4 minus 1 is 3. My new U limit of integration is 3. If I put 4 in, 4 times 2 is 8 minus 1 is 7. And now I have a brand new transformed integral in U world. And I'm all set. Now I can just execute the integral. Right? I can evaluate this thing and be good to go. So let's go to work. I'm going to add 1 divide. Equals, add 1, u to the 3 halves. Divide is like multiplying by the reciprocal, so I'm multiplying this by 2/3. See you later 2's, I get 1/3 u to the 3 halves, evaluated at 7 and at 3, equals, well this is gonna be ugly, but yeah, okay, I'll take it. 1/3 times 7 to the 3 halves power minus 1/3 times 3 to the 3 halves power. And as far as I'm concerned, what's right is right. That answer is good by me. That's not going to simplify that at all. Like I could write that as the square root of 7 cubed and the square root of 3 cubed. That's not going to simplify anything more than just having some roots in there. So I like that answer as a final answer. I actually like that answer as a final answer on an AP test. They assume that you can add, subtract, multiply, and divide. You really wouldn't have to go any further than that. Yes.
Like on an FRQ, like if they gave you that, could you just leave it like that?
Yeah, you could. They don't assume that you can evaluate trig. So like sine of pi, gotta let me know it's 0. This guy, cool. Circle it. Next question. We'll practice that, we'll work on it. So in this problem, if you would have done this integral in terms of u, gone back to x and then plugged in 4 and 2, you get the exact same thing. Think about it. You'd be putting 4 into your result. 4 times 2 minus 1, 7. You'd have the 7 there inside. It's the same process. This just streamlines it a little bit. It also will help you answer a multiple choice question that they love. They love to say, here's some integral. This integral is equal to which of the following, A, B, C, or D? And really, what it's equal to is this integral. They'll do different things with it. They'll be like, choice A, the integral from 3 to 7 of u to the 1/2 du. Okay, well that's wrong. It didn't account for the 1/2. Choice B, the integral 1/2 times the integral from 2 to 4 of u to the 1/2 du. Well, that's lovely, but they didn't change the limits of integration. They forgot about that part. That's probably the one that most people pick incorrectly. Maybe choice C is like the combination of the two. Maybe choice C is just the integral from 2 to 4 of u to the 1/2 du. That's for the person that has no clue what's happening. And then choice D is the winner. 1/2, but this is equal to this in U world because that relationship existed. Questions?